Okay, friends. So now we are going to use all these three laws and try to solve problems. Okay. Now, in order to solve any mechanics problem, one thing which is common across is free body diagram. All right. Now, this may not be a separate topic altogether in your textbook or something, but then it is one of the process which is followed by to solve every problem. All right. So it is important for us to understand how we can draw free body diagram in a proper way. All right. So this all these I have listed down the steps which are in very detailed manner. All right. But then natural tendency of a person to draw free body diagram and to find the final answer, in order to follow all these steps, the natural tendency is to skip lot of steps and arrive at the answer at a faster pace. But what I request you is, you can skip the steps in the exam, but then since this is a learning process, make sure you follow all these steps properly, no matter how much time you take to solve a particular question. Okay, because your number of problems solved by you is not proportional to amount of marks you get. Amount of marks you get is proportional to what is your understanding of the concept. Now, your concept will be developed only when you follow the basics numerous number of times. All right. So make sure you follow the steps properly one by one for all the problems that you are practicing. Okay. So let us understand step by step what all these process steps for free body diagram actually mean. Okay. So first step is to choose a mass for the analysis. Okay. Now, how many equations we have discussed for laws of motion chapter? There is only one equation till now we have discussed, which is force is equal to mass times acceleration. Okay, and this equation, force equals to mass times acceleration, how many masses you can apply this equation at a time? You can apply this equation only one mass at a time. Okay, so it might be that in a problem there are multiple masses. For example, in this particular problem, there is one mass here, one mass there. Okay, so multiple masses may be there, but this equation you can only apply one mass at a time. Okay, so you have to choose one by one these masses. So first I choose, suppose, m1 mass. I'll follow all these steps. Then I'll choose m2 mass. Okay, and follow all these steps, because this equation can't be applied to both m1 and m2 together. Okay, so step number 1 is pretty clear. You have to choose which mass you want to analyze. Okay, now the next step is to pick a suitable coordinate axis. Now we know that Newton's second law is a vector equation, right, which says that vector F is equal to mass times vector A, and we want everything to get reduced to scalar equation. It is easier to deal with scalar equation, right? So we want to write it like this: sum of all forces, external forces, is equal to mass times acceleration along x-axis, and similarly for y and z-axis. I want to write down like this. Now you can only write down like that when you know what is your x and y axis. Okay, so you have to choose your x and y axis. You can choose any x and y axis, but make sure x and y axis are perpendicular to each other. Okay, so it is always user's choice. Now since it is a user's choice to choose which is your x and y axis, it becomes at times tricky to to identify which is the most suitable coordinate axis. You will get answer for whatever coordinate axis you take, you will get the same answer, but the number of steps may get reduced drastically if you smartly choose your coordinate axis. For example, we are talking about step number 2. For example, this is a mass which is sliding down with acceleration A. Okay, it will experience normal reaction mg, and suppose it will experience friction also. Okay, now usual tendency of ours is that we will generally take x and y axis horizontally. Okay, if you take x and y axis horizontally, then these vectors, these forces, normal reaction, friction, acceleration, these vectors are not along any axis. So in order to write down these equations, Fx is equal to mass times acceleration along x-axis, you have to take component of forces. Okay, all three will have four component along x-axis. Right? In order to simplify the equation, it is a better idea to choose coordinate axis in such a way that many vectors are already along the coordinate axis. For example, if you take your coordinate axis like this, okay, if you take your coordinate axis like that, then friction, acceleration, they are along x-axis, and normal reaction is along y-axis. Now only force which is not along any axis is mg, and only mg's component you have to take now. Okay, so this will be more clear as and when we solve more numericals, but remember that you have to pick those coordinate axes for which the vectors acceleration and forces, many of them are already along those axes. Okay, then it will be comfortable for you to solve the equations. All right. So step number 3. Step number 3 says draw all the forces on the mass as arrows. Like the one which we have just drawn. Okay. And tail of the arrow touches the mass and head shows the direction of force. For example, I want to draw normal force which this wedge applies on the mass. Normal force always pushes and it is perpendicular to the contact surface. So direction will be perpendicular and it will push. So this is the way you should draw the normal force. It should touch the mass and the direction should show the head should show the direction of the force. And friction force is shown like that. This is friction. Okay, and mg is shown like this. This is gravitational force. Okay, now these are all the forces, and then you have to identify angles the force makes with the coordinate axis. Now I am assuming that you guys must have taken this as your x and y axis. Then I have to mark the angles these forces makes with the x and y axis. You see that normal reaction makes zero angle with y axis. I don't need to mark angle for normal reaction. Similarly, friction makes zero with x axis, so I don't need to mark angle for that as well. But for mg, I need to mark the angle. So this is line which is parallel to y axis. I have to find out what is this angle. If this is theta, you will see that this is also theta. Okay, so this is step number 3 to 6. All right. Then in step number 7, I need to resolve forces along axis. Those forces which are already along x and y axis, I don't need to resolve them. Okay, only this mg force which is not along any axis, I need to resolve that. So mg, component of mg along y-axis in downward direction is mg cos theta, and along x-axis is mg sin theta. Okay. Now once you take component, it means that mg vector is a sum of these two. Okay. So I don't need to show mg now. So we can safely remove mg because mg is equivalent to its components, right? Fine. So this is step number 7. Now step number 8 says that you have to show the acceleration as an arrow which do not touch the block. So I say that it tries to go down with acceleration A. So this is step number 8. Okay. Step number 9 says resolve the acceleration along the axis. In this case, acceleration is already along the negative x-axis. I don't need to take components, okay? Because its component along y-axis will be 0, since y-axis is 90 degree to the x-axis. Now, many a times you will see that acceleration also makes an angle with axis. Then you have to take component of acceleration as a cos theta and a sin theta. Okay, we'll deal with those kind of situation little bit later. Okay. Now, equation number 10, sorry, step number 10 says identify the motion constraints. Now, have we already identified the motion constraint or there is no motion constraint in this situation? We have actually inherently assumed that there is a constraint. We have assumed that this wedge is fixed and we have assumed that this block, if it has to move, it will move only along this path. That is its constraint. Okay, so we have already subconsciously assumed the constraint while doing all this. Okay, but many a times it is not quite obvious. You may have to find out. Okay, so there will be a separate video on constraint motion itself. So we'll deal with some of the not so obvious cases wherein we'll learn how we deal with such kind of tricky situations. Okay, so this is step number 10. Step number 11 says write down force equal to mass and acceleration along all axes. So let us do step number 11 for this particular case. So I have to first write down sum of all forces along x-axis is mass time acceleration along x-axis. Okay. So along x-axis, what are all the forces? The forces are, I'll take positive x-axis as positive. So friction minus mg sin theta is a total force along x-axis. Fr is in positive x-axis, mg sin theta is in negative x-axis. This is total force. This must be equal to mass time. Now acceleration I have taken in negative x-axis, so I have to write down it as m into minus m. Okay. Now one thing is to assume signs using coordinate axis. Another way which people usually feel comfortable with is they can assume any direction of force along x-axis to be positive, and along that direction, if acceleration is there, then that is also positive. For example, if I already know acceleration is in this direction, I'll say whatever direction of acceleration, in that direction forces are positive and opposite of direction of acceleration is negative. Okay, so I don't even look at that coordinate axis. So I'll say that mg sin theta, which is along the direction of acceleration, is positive, minus frictional force is mass time acceleration. Now I'm saying acceleration is in the direction of mg sin theta, so both are positive together. So we'll get the same equation actually. Okay, but in first case I have taken the sign convention from the coordinate axis. In the second case I have taken sign convention from the force itself. Okay, so I think this is more comfortable, and almost everyone follows this type of writing itself. They take the sign convention from the direction of force. So along the direction of acceleration, you say that forces are positive. Opposite to direction of acceleration, you say forces are negative. So like that. And sum of all forces along y-axis is mass time acceleration along y-axis. Now, in this particular case, this is the y-axis. Total force along y-axis is n minus mg cos theta. And what is the acceleration along y-axis? And we have assumed here is that since it is a constraint to move along the incline only, there cannot be any motion perpendicular to incline, right? So this must be equal to 0. So these are the two equations we have got from Newton's second law. Now, how many variables are there? Let us count. Fr is one variable, normal is second, and acceleration is third. So we have three variables. We need a third equation. We can't solve it like this. Okay. So for third equation, we have to go back and remember the things which we have learned about forces. We have learned that if an object starts to move, then friction must be equal to kinetic friction coefficient into normal reaction. So in this problem, kinetic friction coefficient must be given. Okay. So now I have three equations and three variables, and I will easily solve them to get the answer. So step number 11 and 12. Okay. So this is how you solve every mechanics problem. Now what we will do next is we will take up few more situations and we'll apply all these steps and see that how we can deal with different kinds of scenarios.